Someone asked about what happens when agents interact, and I'm going to tell you all about that. So, as we've seen, several studies have shown that AI can accurately replicate human behavior. This includes published and unpublished studies. So a lot of times it's psychology studies or economic games, which can be very similar. So not all the time, but a lot of similarity. And it's the unpublished ones that are particularly interesting, because you might worry if they're already published, maybe the AI is just repeating what it should know, but it's not. One of the papers that Tanny talked about was this. This is the agents has multiple meanings. One is the one where Matthew McConaughey is in a Super Bowl ad and didn't get a table. Okay, and that's because the right agents didn't book them the right tables. This is another one where the AIs just talk to each other, and they sometimes produce what's called emergent behavior, but things you wouldn't expect. So here, this is sort of like a town, and a couple agents are talking to each other. Hey, have you heard anything coming up about the mayoral election? No, not really. What's going on? So a lot of times they just say boring things like this, the chit-chat that makes up our lives, like boring is a value judgment. But what's interesting is these AIs they observe the world, and then they think about what they see, and then they act in some way. They move to a new location, they say something to somebody, they'll pick up an object, something like that. So it's a very interesting framework, and it's realistic, but the question is whether we can actually use AI to simulate complex behavior outside of the lab. So, I have lots of studies. I'm going to show you just two. So it's called the shopping cart return study, and we've done it in simulation. So if you've ever been to a store with a parking lot, which you haven't in New York, there's this problem of you've got the cart, and do you actually take it back to the receptacle? On average, so this is not a study where people go to the lab and get paid money. People just observe people in the parking lot. So it's really an in the wild thing that you can observe. And so there's none of this study limitations. You measure so about 80% of people take it back. But if people have something that's pressing them, some sort of stressor situation, they have a child in the car, this number goes down. So this is something that we can test for when we have these agents and we put them in a virtual parking lot with a virtual shopping cart and a virtual receptacle for returning them, and then give them a virtual child in their car. Do they do what people do? So they got to take it to the receptacle, and they go off about their merry day. So having a child is one of them, and the other was the part that the receptacle is really far away. Okay, and in this, we actually see exactly that when you have a child, it goes down to 20%, which is a little bit lower than what real people do, which is about 30%, and then just it being really far away reduces it from 80 to 40%. So this is kind of exciting, because we didn't tell these agents to return their cart or not. We just said, you're in a shopping cart, you got to get home, you've got this kid in your car, and we just let them think, act, and behave. They can interact with other people if they want, like their child, but it's sort of just like in the wild. So this was the baby one. This is literally the baby one. What I really wanted to do is, as a professor with 600 students in my class, I am every year tasked to come up with a late policy that will reduce the amount of emails that I get with questions in them. It's very hard to make this late policy. It's very hard to test it, because you get things. Okay, so I simulated a small classroom with a professor and some students, and there's various different late policies I can test. A really harsh one, a sort of, work-life balance one, and then a really lenient one. What are the students gonna do? I also think about different student personality traits. So we have an overachiever, a procrastinator, and a work-life balance person. I'm the procrastinator, in case anyone was wondering. And the professor just announces these assignments, and then students get to work on them for a couple days. And we sometimes introduce new stressors or perturbations. Those could be a very challenging assignment, or you've got 8 other midterms in your other classes that are stressing you out. Okay, so here we've got our classroom situation. And we actually have a separate room for a workroom that the teacher can't be in, and a separate room for the professor. This means that if the students can talk to each other without the professor hearing, which is very important. So the professor's going to enter their office. Students go off and work on their thing with no professor around. Students can go to the office if they need to ask questions. There's no email in this world. Sounds like a paradise, right? Anyway, but what we see, and we've just told students, you know, you get a grade for doing your assignments. We don't tell them what to do, but they naturally do start doing the assignments. And they start turning them in, which is great for students. But then when we get these emergent behaviors, when we have that strict policy where there's like, if it's 1 day late, you get a 0. And when we have external stressors, like a midterm or really hard assignment, the students start to cheat. The students start saying to each other, hey, could I maybe look at your homework? It's always the procrastinator, and they always know to ask the overachiever. The overachiever always says, yes, I'd be glad to share my solutions with you. So this is very exciting, that we can see the dynamics that I know from being a professor, and having been a student, to be honest, are the real-world dynamics of what happens. Now, I can't say that it happens at exactly the same rate, but it's exciting that we can get these things that we didn't know that we were looking for in the dynamics. We also get students emailing the professor for all sorts of exceptions and this and that and all this stuff. So we've seen multiple kinds of behaviors that we didn't tell them to do, but are I observe in the real world, at least in my classes. Okay? So what are we going to do with this? This is interesting. So I love these two approaches of let's see if we can really get data about people without talking about people. This, I don't know. I think it's helpful. As a professor who is trying to design a late policy, it is nice for me to help think through what the students might do and what the interactions might be. I'm not guaranteed that it'll be the exact outcome, but one thing that you can do with this is now connect these human simulated agents to a system that's trying to orchestrate people to test it. One of the biggest problems we have in AI is we build a system, it's like, oh, this is gonna schedule all your classes for you or email all your students for you, and you're too terrified to use it because you don't know if it will work, you don't know if it will run amok. It needs to be tested very, very thoroughly. Testing that with humans is expensive. Testing it with agents is nearly free. The type of problem that we're tackling with this is called human coordination. So you've got a warehouse and you have to assign workers to jobs. You've got to discover who's available, what resources are out there. It's totally unknown. There's constraints and availabilities that you don't know about. Someone's got a doctor's appointment, someone's kid is sick, someone just doesn't want to come in today, all this stuff. And so you have priorities. People would rather have this, but they wouldn't want to do that. And you have to adapt in real time. You're constantly replanning. These are hard. If you've ever worked with a human, you probably know what I'm talking about. Okay, and this really is it really impacted by human psychology and all the things that can go on inside. You can negotiate. Someone says they're busy. Are they really busy? If you pay them more money, if you make the job sound better, maybe they'll do it anyway, right? So lots of psychological factors at play. And so LLMs can do this on two sides. We have a set of agents who are planning the work for people and suggesting, how can I figure out who's available to work and try to schedule it for them? And then you have human simulators saying yes or no to those jobs. So here is the exact scenario that I look at. I very often have to schedule speakers. There's 14 weeks in the semester. I need to find 14 people who can come on a Friday. This is not an easy job. They all have to come on a different day. They all can't come on the day before spring break so they can then party in New York. All have to come on a different day. And none of them just happen to say, oh yeah, I can all come on day 1, 2, 3. It never lines up. It's always a mess. It's a big negotiation. So how can we, and how many times am I going to email them if they don't respond? Am I going to email them 10 times, 2 times? Does it depend on how famous they are? There's lots and lots of policies so that you need to enact before and decide on, so before the agents can just run amok, before they, I don't know, email Jan LeCun 30 times and now he's going to blackball me for never answer another email. Anyway, okay, so In the very smallest scenario, let's say we have 3 people that we want to speak and 3 slots that we have to fill. And so this is the assignment problem that we have to do. They all have to pick a unique one. Okay? So as an organizer, how would you allocate them? Well, you kind of have to ask who's available when. And you got to figure out dynamically and solve this constraint. Okay, so here we go. 3 speakers. So this could be very easy. We just send them an email. Hey, everyone, which dates are you available? And it's possible that there's no conflicts and someone's like, I want 1, I'll take 3, and I'll take 1 or 2, and it works out. Okay? If that happens, you're really lucky. This has never happened to me in the history of life. But usually, you have to go back to people. Because guess what? Whoever says they're full availability on round 1, they're going to hold the dates that they don't really want to go back from you. So in this easy case, we were just able to get the availabilities and solve the constraint problem and get a result and be done. Now we've got to do more planning. AI is going to help us with this. So let's say there's 1 or 2 conflicts. So we've got person 1 could come on slot 1, someone's available for all 3, someone can come on 1 or 2. All right, so now we've got a problem. What are we going to do? We can do some allocation, but it failed because no one's actually available. We can't have someone on all of them. But the AI can think, all right, I have to ask somebody to negotiate. I have to ask someone to say, could you please, please, please come on 1 other date so we can schedule this thing? So it has to decide who it's going to email, how it's going to say it, how convincing it's going to be. And at first, it doesn't know how to do that. But by running various simulations with lots of different users and asking me, the user, what I prefer in certain scenarios, it can figure out good policies for how to do this. Like, how many times should it continue to ask? How much should it negotiate? If someone's faculty versus a student, all these sorts of edge constraints. So we do this. And we'll go back to someone, hey, I have a conflict, any chance you can do slot 2 or 3? If they don't do it, you'll have to go to the next person, they'll get that email, and then we'll be able to have an allocation. Yay! So we've seen the easy case, we've seen the medium case, and there are even harder cases. Now, it could be unsolvable. That is an important distinction to make, and we have to decide when it is unsolvable so that we don't email people anymore, just sort of give up or find someone else to ask. But we can, in these hard cases, at least learn some of that behavior in simulation so you're not doing it when you're really allocating it. So this is what we're really doing, is learning a policy. Having all these human simulations and the system running in itself, it can ask me, the organizer, what my preferences are so that it can go off and be at least somewhat trustworthy in how it sends these emails, how it asks, when it asks, and so that I get the schedule that I want without having to do nearly as much work. So I'll blast through these hard cases. But the AI is used here let me just go through some of these. Oops, you've seen these are the hard ones. It does this loop between planning and sending these emails, which are both agentic things to do, and then running the simulation and doing dynamic replanning, checking if the matching is right, plan, re-execute. Oops. Ugh. The AI is composing all of these emails by itself. It has to interpret what people are saying. And sometimes people don't say unambiguous things. They'll say, like, oh, I might be able to come on the 3rd. I don't know yet. Check back with me. Then it has to remember to check back with them. When should they check back with them? All of that, it has to decide, which is great for me because I'm terrible as a human being at doing that. I'm like, I guess you're not speaking because I'm not going to remember to call you back. Anyway. So sometimes it takes multiple, I'll just go through these. So when we do this in simulation, we can solve all the solvable cases. So that's great. Because you just keep emailing until you get responses that you need when it's possible. The question is, how many times do we have to ask? And right now, this depends on the planner. Like if the planner can come up a good plan, then it can ask very few times. So in the easy case, it doesn't have to replan. There's no conflicts. In the medium case, on average, has to ask 1.5 people. Sometimes it gets lucky, the first person can switch, and then sometimes not. In the third case, it actually has to go back to people almost 4 times. We're trying to reduce this, but it's unclear if it's actually possible. But this would be great. Imagine you didn't have to send emails like this. I don't think that this is the kind of job that I should be spending half my life doing, and yet I am. I think that workplaces are full of these allocation problems that have some human component where you have to ask them their availability, and they have to answer. And instead of doing that, we can have really well-guided systems that are based on human simulation. So one of those use cases of simulation is to test these automated human agent systems that otherwise would be very difficult to trust in areas where you actually want to respect humans' time and preferences. That's what we've been working on. Because it has 2 kinds of agents and 2 types of loops, we call it double agents, pun intended. I will take any questions that you have. Did this satisfy your curiosity about agents interacting? Excellent. Has anyone ever cheated it? No, let me ask. Cheated in the class when it got too hard? No, none of us. Absolutely not. Yeah, please. I can hear you. Oh, okay. Now that's better. Technology for the win. Let's do it.
So one question I guess would have, if we take some of this part of it, I love the approach of basically trying to get automated coordination systems to essentially function better by having that testing, right? Instead of, I think a lot of times just skipping that altogether because of the cost factor. I wonder though, however, does knowing that, do the human, if we take like factory setting, for example, if the workers know that their preferences have been simulated, does that then change some of that behavior in the sense that like it takes a lot of the empowerment out of them, right? We've already simulated sort of their decision, we simulated their preferences. Like there's optimization, but I wonder at the personal level, how does that possibly change individual behavior?
Certainly, if I am being trained on, if I'm a worker and I'm being trained on, I might have an incentive to give dishonest answers that mess up the training data so that it does something different. So for example, people use incognito mode when they don't want to be tracked for something that they are doing that is unsafe or illegal. So we all do these activities. I think I would hope in a lot of these cases, everyone wants the right allocation of work. Everyone, like if I want my preferences to be taken into account, I agree that the planner has a little bit more market power, and you do see this, that you can really overschedule people and like really optimize, but pay possibly too much human time so that you have like 38 minutes of work this week. And so there is some of that could happen, but I think there's a market power issue that we have to go from the other side. Maybe there's an overall better allocation. I mean, there's a lot of research that shows that people aren't that effective after 60 hours of work a week. I do a lot more than that, and I'm definitely not effective, but there you have it, beyond those hours. So there are some known limitations that maybe if everyone saw that, okay, you work people too hard, that's actually not productive, we could sort of negotiate an equilibrium where everyone gets the best. Because a lot of times those exist, those like win-win scenarios exist, you're just not exploring the right spaces. So that would be my ideal of how this would happen. What fun question. Okay, I will hand it off. Thank you.